Let's do an example. Determine if the set v1, v2, and v3 is linearly independent. The first vector v1 is given as this vector, and v2 is given here, and we have v3. Okay, so we want to know if this set of vectors is linearly independent. Let's form the matrix. Form the matrix that has v1, v2, and v3 as columns. Okay, so let's take v1 and form the column. Take v2, form the second column, and v3 for the third column. And we want to know what C1, C2, and C3 are. This is our column vector of the weights, C1, C2, and C3. Set that equal to 0, the 0 vector, which has zeros in every entry. Now, we want to know if this system of equations has only the trivial solution. Okay. Let's form the augmented matrix. And then let's try to do a bunch of row operations on this augmented matrix to solve for the solution. And if we get the trivial solution, then we know that that would be the only solution. And so the original set of vectors would be linearly independent. If we find that this system of equations actually has non-trivial solutions, then we know that the original set of vectors are linearly dependent. Okay, so let's look at the first two rows. Okay, let's add the first two rows. So R1 plus R2. That'll give us our new row 2. Look at the second and third rows. Let's take the second row and subtract the third row. And let's make that our new third row. Look at the second row. Notice 7 is the leading coefficient. Let's make that a 1. So divide out by 7. Okay, look at the second row here. Notice the variable for C3 is free. It could be anything, so let C3 be T, a free parameter. Now, from the second row, we know that C2 plus C3 is 0. So plug in T for C3 and solve for C2. Okay, we get minus T. From the first row, we get C1 plus 3C2 plus 13C3 equals to 0. Plug in minus T for C2. Plug in T for C3. And simplify. Solve for C1. And I get minus 10T. Okay, so now we have C1, C2, and C3. Let's plug the values in for each of those C values. We get minus 10T, minus T, and T. Let's factor out a T. Okay, so our set of solutions looks like this. It's all multiples of this vector, minus 10, minus 1, 1. So there's a bunch of solutions here, and they're non-trivial, meaning that they're not zero. They're not the zero vector. Okay, now since the system has a non-trivial solution, the set V1, V2, V3 is linearly dependent. So for example, let T be 1, then C1 is minus 10, C2 is minus 1, C3 is 1. That's from plugging in T equals to 1 here. Okay, so I would just get minus 10, minus 1, 1 for my C values. Okay, that's what I have here. Remember that this matrix equation is equivalent to the vector equation, which has a linear combination of the column vectors of this matrix and weights C1, C2, and C3. So we would have C1 V1 plus C2 V2 plus C3 V3 equals to 0. Plugging in the values for C, we get minus 10 V1 minus V2 plus V3 equals to 0. So this vector equation here is true, and therefore we have a linear dependence relation between the vectors v1, v2, and v3.